Question 9. We have a cube and we cut the tetrahedron from the cube. M and are midpoints of two edges, and H is a vertex. Let's find the ratio of the surface area of the tetrahedron to the original cube surface area. Okay, we can simply assume the cube is unit cube. Let's see the edge length is 1 for the cube. And let's try to find the surface area of the tetrahedron. So the tetrahedron has 4 faces. Let's calculate area for each face. Triangle DMN, the area equals 1/2 times dm times dm, because this is a isosceles right triangle. The area equals 1/2 times 1/2 times 1/2, which is 1/8. And the triangle DMH, the area equals 1/2 times dm times dh. This corresponds to 1/2 times 1/2 times 1. That is 1/4. Okay. Similarly, triangle DNH has the same area, which is 1/4. Okay. Now we need to calculate the area of triangle MNH. For triangle MNH, we can solve the length of each side. So MN equals 1/2 √2. Okay, and okay, let me write MN equals dm square plus dn square and then square root. And then both dm, dn are 1/2. So this is 1/2 √2. And dn, okay, dn is 1/2, dh is 1. So we can solve nh. nh equals dm square plus dh square. This equals 1/2 √5. And this is equivalent to mh. Okay, so √5/2. √5/2. And then let's find the height here. This is an isosceles triangle. So let me call it this midpoint h, the foot h. We have hn equals 1/2 mn, which is √2/4. And then we can apply the Pythagorean theorem to get h. Sorry, I should change my notation. This, I cannot use h anymore. Let me call it p, okay? So HP okay, so we can solve the height ph. Oh, sorry, MP, okay, MP here. pH equals hn square minus pn square by Pythagorean theorem. This equals 3/2 √2, okay? And then we can solve the area, right? Triangle MHN, the area equals 1/2 times MN times pH. This equals 3/8. Now let's add these these 4 numbers. 1/8, 1/4, 1/4, and then 3/8. That's the surface area for the tetrahedron, right? Tetrahedron. This is 1/8 plus 1/4 plus 1/4 plus 3/8. This equals 1. And now we know the cube. We know the cube has surface area 6. Each 6 faces. Each face has area 1. So it's 6. So the answer is 1 to 6. Question 10. We have a geometric sequence with the ninth term equals 1. Sn is the product of the first n terms. Which of the following is correct? So let's denote the common ratio by R. And we have A9 equals 1. That means A10 equals A9 times R, which is R. And A8 is A9 divided by R, so it's 1 over R. And from here, we see some pattern. We note that if we have the product of the first 7 terms, which is S7, and this equals A1, A2, A7 times A8, A9, A10, because the last 3 terms has a product 1, okay? But this new product equals equals S10. Now we have S7 equals S10. So by similar idea, we may find some other equations. For example, I have A11 equals R squared and A7 equals 1 over R squared, right? So from here, we have S6 equals A1, A2 up to A6. This equals A1, A6 times additional 5 terms from A7 to A11. This later 5 terms has a product equals 1. So S7 actually equals S11. Now we don't have such a choice in the problem. So let's do one more term. Say we have A12 equals R cubed and A6 equals 1 over R cubed, right? So we can consider the product of the first 5 terms, A1, A2, up to A5. This equals A1, A2, A5 times additional 7 terms, say A6, A7, A8, A9, A10, A11, A12. This 7 terms has product equals 1. So the answer is S5 equals S12. So the answer is C. For the question 10, we can also do it in the regular way. We express everything in terms of the initial term and the common ratio. So we still denote the common ratio by R, and A9 equals A1 R8. This equals 1. That implies A1 equals 1 over R to the 8th power, which is equivalent to R to negative 8. And for general AN, this equals A1 R n minus 1. Let's express Sn in terms of A1 and R. Sn is the product of A1, A2 up to An, and this equals A1 times A1R, this is A2, and up to A1 Rn minus 1. So there are n terms. We have A1 nth power and R. The exponents are from 1 to n minus 1. It's easy to see this equals A1 n R n times n minus 1 divided by 2. And note that A1 is also a function of R. So let's write everything in terms of R. So this is R minus 8n times R n minus 1 over 2. And then we can combine these two exponents. Which is equal to R to the exponent n times n minus 1 divided by n times n minus 17 divided by 2. And let's check these choices. And you will see S5 equals S12 because S5 equals R 5 times negative 12 divided by 2. And S12 equals R times 12 times negative 5 divided by 2. So these two terms are clearly equal. So we have answer C. Question 11. ABC is a isosceles right triangle with angle B equals 90 degree. And D is the midpoint of BC. And the BE is perpendicular to AD. EF perpendicular to BC. We need the ratio EF to AB. So let's assume the sides AB equals the side BC equals 1. It doesn't change the ratio, okay? So we consider the right triangle A, B, D. Okay, this right triangle is similar to triangle BEF, the red one and the blue one. Okay, because AD is perpendicular to BE, we see that angle BAD equals 90 degree minus angle ABE. That equals angle FBE. And both triangles are right triangles, so they are similar. PFE. And now we know the ratio. AB over BD equals BF over EF. And this equals 2 because D is the midpoint of BC. This equals 2. Okay, let's assume EF to be X. And the triangle EFC is also a isosceles right triangle. So FC is also equal to X. That means we have BF equals BC minus X. So it's 1 minus X. Okay, so from the above equation, we see that BF is 1 minus X over EF, which is X. This equals 2. From here, you can solve X equals 1 over 3. And of course, the answer EF over AB is 1 over 3. The answer is B. Question 12. We have a straight line that's tangent to two circles in the coordinate system. And what's K times B? Let's draw the picture. The first circle, O1, is a unit circle. And the second circle, let's complete a square. So we have x squared minus 8x plus 16 plus y squared equals 1. That means this is a circle, x minus 4 squared plus y squared equals 1. This is a circle centered at 4, 0. Let's mark the center here. 2, 3, 4, 5. So the circle is here. And we have a line tangent to both circles. Basically, there are two possibilities. Okay, this line must pass through the midpoint of the line connecting two centers. So the center here is 2. So the line must pass through 2 because the midpoint of these two circle. Okay. Or there's another case with negative slope. We can choose either one because they just change the sign. Let's consider the red one, the positive slope. Let's call this y equals kx plus b. And I will connect the center and the tangent point here. This radius equals 1. And let me mark this point. This is, let me call this A, the center B. This is C. Triangle ABC is a right triangle. And we see that AB equals to BC. That means we have angle CAB equals 30 degree. Okay. This angle equals 30 degree. All right. Now we know the degree. We know this slope. So similarly, I can connect the other part here. Okay. This is O. And this is, let me call it D. The y coordinate of D is equal to the y-intercept B, okay? Now let's calculate the slope and the intercept. The slope K is basically tangent 30 degree, right? Which is root 3 over 3. And the y-intercept B equals, okay, OA is negative, okay, OA divided by root 3, right? This is a special triangle, 30 degree, 60 degree, 90 degree. So OA divided by root 3 is minus 2 over 3. The product KB is simply root 3 over 3 times negative 2 over root 3, which is negative 2 over 3. The answer is B. Question 13. We have a unit circle and a fixed point on the circle. We rotate the circle about this fixed point by theta degree, theta between 0 and 180 degree. What's the probability that this area swept by this rotation is no greater than 2 pi? Let me draw the graph. We have a unit circle. And let's see, A is this point. And we rotate A by theta degree. It's basically, let me draw an arc with radius 2, because this is the diameter of the unit circle with radius 2. So let me draw this. It's basically the path traveled by the other point on the diameter. So finally, you may stay here. Okay, this is the result, right? So let's see what's the area of this region, of this region. So this region consists of, let's say, 3 parts. We can divide this into 3 parts, 3 pieces. 2 semicircles of radius 1. This is 2 semicircles. And a sector of radius 2 with angle theta, right? That's theta. Theta's here. I mean, maybe theta's here. This is theta degree. What's the area? Let's express the area. 2 semicircle provide a complete circle of radius 1 pi r squared plus theta divided by 360 degree times pi times 2 squared, because the radius for the red sector is 2. Now this corresponds to pi plus theta. Okay, 360 degree is basically 2 pi, right? So let me write this way. This is 4 pi. This should be no greater than 2 pi. So that's equal to 2 pi. That means theta over 36 degree plus equal to 1 over 4. That means theta is less equal to 90 degree. That's the requirement. Okay, in this problem, theta is from 0 to 180 degree. The value degree takes 1/2. So the probability is 90 over 180 equals 1 over 2. The answer is 1 over 2, C. Question 14. The inequality has exactly 3 integer solutions. What's the largest possible value of k? First, we note that x cannot be 0. So we can divide x squared on both sides. K larger than x minus 3 squared over x squared, and this is equivalent to 1 minus 3 over x squared. This inequality has 3 integer solutions, and exactly 3 integer solutions. Let me denote this as a function f, and we try to find the 3 smallest values for the function. First, we note that if x equals 3, the function has the minimum value, which is 0. And if x decreases, say x equals 2, the value is slightly larger, 1 over 4. And if x equals 1, f1 equals 2 squared, which is 4. And x cannot be 0. If x is negative, fx must be larger than 1 squared, right? This 1 minus 3 over x is larger than 1. So f is larger than 1. Okay, on the other hand, if x increases to 4, f of 4 equals 1 over 16. If x equals 5, this is 4 over 25. If x equals 6, this equals 1 over 4. And if x is larger, the value is larger. So x equal to 7. f7 equals 16 over 49. So it's larger. So if x increases, the value is increasing. All right, let's pick the smallest 3 values here. They are 0, 1 over 16, and 4 over 25. Other values are larger. Now, in order to have exactly 3 solutions, that means k must be larger than 4 over 25 and less equal to the next value, which is 1 over 4. If x is larger than 1 over 4, we will have at least 4 solutions. So the largest k should be obtained at 1 over 4. Question 15. We have a formula y squared equals sine x squared. Which picture corresponds to the graph? All right, let's study this equation, y squared equal to sine x squared. First, it's symmetric with respect to x-axis because y squared equals sine x squared. There are always 2 branches. Y equals sine x squared and y equals negative sine x squared. So symmetric with respect to x-axis. Of course, we require this to be non-negative. So from this observation, we can exclude B and the E. So B, E are not correct. This is the first observation. The second observation is that it passes through the origin. Zero, zero is on the graph because when x equal to 0, sine x squared equals 0. So this implies we can cross out D. And the third observation is that we may not have the graph for every x. X is not on, it does not have graph. It does have graph. For example, if x equals 3 pi over 2, let's say square root. For such x, we have y squared equals sine x squared equals sine 3 pi over 2, which is -1. No solution. Okay, that means the graph does not cover every x. So from this observation, we can exclude C. We can exclude C. So finally, the answer is A. So we choose A. For question 15, we can also sketch the graph based on the equation. Let's first record the graph for function sine. So y equals sine. This is a periodic function. So the graph is 2 pi periodic. And it's odd function. It's symmetric with respect to the origin. Okay. This is sine x. And then we consider y equals sine x squared. Well, this time the function is symmetric. If you plug in x or negative x, the value is the same. So the function is even function. Let's draw the picture. And on the other hand, if x is large, x squared increases faster and faster. So it goes through 2 pi faster and faster. So something like this. If x is larger, it x squared increase faster and faster. So the graph is something like this. It's more and more dense, okay? And it's symmetric with respect to y-axis because it's even. So the other piece, basically we just do reflection. Okay, something like this. And it becomes very dense, okay, like that. And for future part, it's very, very dense. Okay, something like this. And then we consider y squared equals sine x squared. So this is basically we take square root. Okay, take square root for sine x squared. And this we can only do this for non-negative value, right? And for sine x squared to be negative, there's no graph. So basically, we only have the non-negative piece, say this piece, and this piece, and this piece, and this piece, and this piece, okay? We can only take this red piece, take square root for the red piece because they are non-negative. And instead, for the blue part, the negative part, there's no value. So in this observation, we can roughly draw the graph as follows. Because there are two branches, positive branch and negative branch, we have this piece. And then we have some jump to here. Here. Take square roots, right? And here. Take square root. And then maybe later in this piece. And the other part is symmetric. Okay, symmetric. And here, sorry, it's totally symmetric. I hope this idea is clear. And now we have a thinner and a thinner piece, very thin piece like that. So the only matching picture is choice A. Question 16. We have n numbers between 1 and 2021. The largest number is 2021. The average of every n minus 1 numbers is still an integer. What's the largest possible value of n? So let's denote the sum of this n number to be s. Every n minus 1 number is divisible by n minus 1. That means the sum of every n minus 1 number, let's say s minus aj divided by n minus 1 is an integer. That means s minus aj is a multiple of n minus 1. In other words, it has remainder 0 when it's divided by n minus 1. So similarly, if I choose a different number, ai, s minus ai, some other choice of n minus 1 number, is also a multiple of n minus 1. Now I can do subtraction. That means the difference of any two numbers. Here we have ai minus aj has remainder 0 when divided by n minus 1. In other words, ai and aj has the same remainder when divided by n minus 1. So for these n numbers, they have the same remainder when divided by n minus 1. So let's take this remainder to be r, it's common remainder. And we can list all possible numbers that has remainder r when divided by n minus 1. They are the smallest possible value, and n minus 1 plus r, 2 times n minus 1 plus r, and n minus 1 times n minus 1 plus r. So these are valid numbers, and they are smallest possible value numbers, okay? And smallest valid numbers. In our problem, a1 to an, they may be larger than this number, okay? So in this problem, the largest number is 2021. Here, the largest number must be at least, okay, 2021 is an. The largest number an is at least n minus 1 times n minus 1 plus r, okay? So that means we have n minus 1, okay, 2021. Let's do this way, okay. 2021, this is larger equal to n minus 1 square. So 2021 larger equal to n minus 1 square. This implies when you take a square root of 2021, it's smaller than 45 square. So this is n minus 1 is at most 44. So that means n is less equal to 45. Okay. And let's see if 45 can be obtained? The answer is yes. Let's double check. Take n equals 45. And let's check this. Let's write down this number r. 44 plus r. 44 times 2 plus r. 44 times 44 plus r. Okay, we are looking for an such that it's equal to 2021. But 44 times 44 is a little bit far from 2021 because we require the remainder r is between 0 and n minus 1. Okay, but 44 times 45 is still less than 2021. So we'd better write one more term. 44 times 45, this is closer to 2021. Okay, if we set this number to be, okay, this is 1980, okay? It's very close to 2021. Here we can solve the remainder, r equals 41. This works. It works. So we can just take any 45 number from this 46 number. That will work, okay? Just take any 45 numbers from above. Say I can just take any number, like I can take 44 plus 41, 44 times 2 plus 41, up to 44 times 45 plus 41. This applies, and A1 to AN, they are different choices, but this is one valid choice. In other words, n equals 45, that's the largest possible value. Question 17, we have this tetrahedron, and CA, AB, BC, CD, DB equal to AD equals root 6. It's 2 everywhere except AD. And we rotate this about around the BC. We need to find the sum of the traveling distance of D and A. Okay, this is very symmetric. Let's pick the midpoint of BC. Let me draw a larger picture here. Root 6, 2, 2, 2, 2, 2 everywhere. Now I pick the midpoint of BC. It should be the height, the altitude, right? And let's connect D, say M, DM. And we can calculate the height AM because ABC is an equilateral triangle. And triangle BCD, they are both equilateral. That means we have AM equals DM equals root 3. Okay, now let's consider the triangle AMD. AMD, because AD equals root 6, AM equals root 3, DM equals root 3. That means triangle AMD is a isosceles right triangle. Isosceles right triangle. So if we rotate the tetrahedron around the BC, both A and D travels around this arc by 90 degree, okay, by 90 degree. Let me zoom out. So this, if I rotate, I will get the result as follows. Right? Here's A, here's M, here's D, right? So both of them rotate 90 degree, and the radius is root 3. So we just calculate the arc, the length of arc, 2 pi times the radius root 3, and both of them have 1/4, but we have 2, so times 2. This gives you root 3 pi. That's the answer. Question 18. We have this 6 numbers and totally 8 digits. They can form 8-digit numbers. Let's try to find how many different 8-digit numbers can be formed. So first, let's just calculate the total permutation. Because the leading digit cannot be 0. So the first digit, the first few digits, maybe 2, 1, 9, 20, 19. There are 5 choices. 5 choices. And for the remaining part, there are 5 items to choose. There are totally 5 factorial. So this gives you total permutation, which is 600. But of course, some cases are overcounted, right? Some are overcounted. So we need to subtract these overcounted cases. There are 2 possibilities to produce overcounted case. Case 1, if 2 and 0 are together in this way, 2, 0, 1, 9, because we already have 2, 0. In this case, we have overcounted cases. How many cases in this? We have totally 5 terms, okay? And 2 of them are equal. So we have 5 factorial divided by 2 factorial. That's the number of cases here, which is 60. And there's another case to produce overcounted cases. That is when 1 and 9 are together. Say 1 and 9 together. 20 together. 19 together. Here is similar, but we should be careful because 0 here is free. So this is different from A because for the leading term, maybe 1 digit, maybe 2 digit, there are 4 choices. And for the remaining terms, we have 4 terms, and we just do permutation. And we need to divide by 2 because two terms are identical. So here we have totally 48 cases. All right, but we also know that case A, case B, this AB have some overlap. Okay, have some overlap. Overlap means we have both 20 and 19 together. So we have 2, 0 together, 1, 9 also together. And again, we have some other 20 and 19. Okay, permutation in this of this kind appears in both A and B. So we have here we have 4 permutation divided by 2 permutation, right? Or just 4 choose 2. Here we have 6 cases. Now we can find the total cases in A or in B. So that's the union of A, B. By inclusion-exclusion principle, this is A plus B, number of cases in B minus the number of cases in both A and B, which is 60 plus 48 minus 6. This is 102. So we have 102 invalid, overcounted cases. This is total overcounted. And the answer will be the initial numbers 600 minus the total overcounted case 102. This is 498. And 498, when it's divided by 7, the remainder equals 1. So the answer is 1.